Hello my dears. So in the last class we discussed about the steady state stability, right? Steady state stability. So I will tell you once again, steady state stability is nothing but the stability analysis of a system, or the analysis of the system when we are giving a small disturbance, and after few seconds or few fraction of seconds the system will regain its stability. That type of stability is called the steady state stability. So how can we find the steady state stability, or what tool we used there? We used swing equation in order to find the steady state stability. So m into d square del by dt square equal to pm minus p, or psh minus p, both are same. So that equation is very important. And also we discussed about the the root, right? D square plus k by m into delta equal to 0. We derived that relationship and we found out the value of the root, the frequency of oscillation also, right? If whenever there is a at the verge, at the edge of the stability or the marginal stability point, there will be of course some oscillation. Then that oscillation frequency that we already discussed. So today we are going to discuss very important. It is actually a conscience form, right? It's actually what, my dear, a short form of what we studied in the last lecture, that is steady state stability analysis. So this relation, this is very important, because for a 1 mark question, see, normally the questionnaire or the examiner will not ask you what is the derivation of the steady state limit and all, or the long roots and all, no? The long roots and all, or even directly, for this oscillating frequency and all. The chances are actually for AE level examination or electrical inspectorate like examination, even in assistant professor examination, the chances are very less actually, but they will ask this thing. See, they will ask the means it what it actually is, its essence, correct? Its essence will be asked. So the essence I already discussed in the previous chapters is here. Okay, so this is very important session. Please take a screenshot of this and definitely it will be very useful. So the heading is nothing but stability criteria of a power system. This is applicable to stability criteria, means it is applicable to the power system, right? Whenever we are dealing with the power system, the heart of the brain of the power system is nothing but, my dear, generator. Everything is related with generator or alternator. So this stability criteria of a power system is very important. Let's check one by one. See, my dears, I already explained it, etc., that whenever the value of k will be greater than 0, then only the system will be stable, right? Whenever the value of k will be greater than 0, then only the system will be stable. Otherwise the system will be what? Unstable, am I right? Otherwise the system will be unstable. Okay, so whenever the value of k will be greater than 0, the system will be safe. So what was the value of k? Dou PE divided by, that is dou by dou del of PE. Electrical power, the derivative of electrical power output with respect to del is called the constant k. At del is equal to del 0, okay, limit, that is for initial del 0, but generally we can say that dou by dou del of PE, that is the value of k. We already discussed it. Whenever that value of k will be greater than 0, we can say that the system is stable. Yesterday we discussed the two cases for with damping and without damping, right? If we are using damping, the oscillation will be slowly dying out, and finally it will attain a steady state limit, even steady state region. And if we are not using any damping, the system will be continuously sinusoidally oscillate, but it is a bounded oscillation. So definitely we can say that it's a stable system. But what is the value of that del? It's very important value. This term is very important. For stability, the value of del will be vary from 0 to 90 degree. The value of del will be vary from 0 to 90 degree. This is actually, this thing is applicable for both transient stability also. Transient stability means the variation of del will be very high. Suppose the initial value of del is 10 degree. Then after some disturbance, the final value will be 80 degree or 75 degree. That type of, or that much variation will be there in the case of a transient stability. But in the case of steady state stability, normally the variation of del will be very less. Suppose we are operating our alternator at a del is equal to 3 degree. You assume del is equal to 3 degree. After some distance, it will be maximum. It will be like 3.5 to 4.5 or say maximum 5 degree. That's all. So in short, we can say that the variation of del will be from 0 to 90. The variation of del will be from 0 to 90. Why this 90 happens, my dear? Because power equation P is equal to what? The basic power equation P is nothing but, my dear, EV divided by X into sine del. So the maximum P will be happens when P max will be happens when del is equal to 90 degree. The P max will be happen when del is equal to 90 degree. So maximum power will be then. Okay, so that is why we are using what? We are using our limit as 90 degree. 0 to 90 degree will be the steady state limit, and which will be stable for k greater than 0. And dou p by dou del less than 0, that means k will be less than 0, then the system will be surely unstable. The unstable operation at that time, the value of del, the variation of del will be from, this is very important, del varies from 90 to 180 degree. If the value of del is vary from 90 to 180 degree, then we can say that surely the system is unstable. Then dou p by dou del equal to 0, that is the value of k is equal to 0, my dear. The value of k is equal to 0, we can say that system will be marginally stable. That means, what is the meaning of marginally stable? Means, if a small increase in the del, it will lead to the system to instability. So marginally stability means at the edge of stability. It is like a thread bridge, you know. In Malayalam, it is a usage that bridge which is made up of a thread. If a person is walking on the thread, no, if he simply don't care about the about his feet, then what happen? He will fall, right? Fall down. So that type of a narrow bridge is actually the marginal stable point. See, if it is slightly we are increasing the del, the system will get into the instability. Before del, I mean below the del, there will be no problem. Below 90, always say stable now. So marginal stability means always at the edge of the stability, or this is nothing but, my dear, del is equal to 90 degree. And we have another expression. In exam, the question may not be like this. The question may be asked this like this also. See, power P is equal to what? EV divided by X into sine delta. Then what will be? Dou P divided by dou del, which is nothing but, my dear, EV divided by X into cos del. Am I right? Or EV divided by X is nothing but, my dear, P max into cos del. So dou P by dou del is also written as P max into cos del. Okay, so dou P by dou del is nothing but a K na. So K will be nothing but P max into cos del. So the same expression can be right here like P max into cos phi, that is nothing but K greater than 0, same thing, stable. P max into cos phi less than cos del less than 0, unstable. P max into cos del equal to 0, marginally stable. So these two methods now, these two methods you have to take care of. This is also very important, because directly you can ask the question, what is the condition for stability, instability or marginal stability, may be asked. The chances are very high, that's why. And also, see, if I am drawing a graph between P versus del, then we can say that del is equal to 90 degree maximum power we will obtain, right? maximum power will be obtained. That's nothing but EV by X. That's nothing but EV by Lect. So less than this region is called to be stable region, and after that it's an unstable region. So this lecture is very important. Actually this screenshot is very important. Okay, you can simply refer it, or you can note somewhere else. It will be very useful to you. Thank you.